Today we are multiplying and dividing rational expressions. So remember, a rational expression is really just a fraction, okay? So let's review how to multiply and divide fractions when it's just numbers. How do you do something like 2/3 times, oh, I don't know, how about 15/17? Something like that. How do you multiply these two fractions? How? What do you mean? Yes, you can multiply straight across, and then you would just have to check to see if your answer could be reduced. But there is actually a slightly better way. Instead of just multiplying and then reducing. Yeah. Yes, you can reduce first, which is nice because it keeps your numbers nice and small. So if there's anything in the numerator that will reduce with anything in the denominator, you're allowed to do that. So I would recommend that you do that. I can reduce 3 and 15 with each other. 3 goes into 3 once, and 3 goes into 15 5 times. Is there anything else I can reduce? It always has to be one thing on top with one thing on the bottom. They can be in the same fraction. They don't have to be. I just need something on top with something on bottom. So now that I've already done that, I can multiply straight across and I get 10/17. That was a lot easier than getting 2 times 15 would be 30 over 3 times 17 is what, 51? And then reducing that? You can, but my gosh, why would you want to bother? If I could just do that instead and keep my numbers nice and easy. Okay? And it doesn't even matter. You could have multiple fractions. Say you had 4/9 times 2/5 times 18, I don't know, 20ths. Something like that. If I wanted to multiply all these together, I would not do 4 times 2 times 18 and 9 times 5 times 20 and then reduce it. You can, but my gosh, why? Let's reduce if we can. Does anybody see anything I could reduce? You just have to have one thing on top with one thing on the bottom. Christina?
2 and 20.
Sure, 2 and 20. Now, what if you had picked the 4 and the 20? It doesn't matter. It does not matter. If you pick 2 and 20, though, 2 goes into 2 once, 2 goes into 20 10 times. Keep going. What else can I do? Yep. 9 and 18. 9 to 9 once, 9 to 18 2 times. Keep going. Here's what you can't do. You can't reduce two things both on the top or both on the bottom. You can't do the 2 and the 4. You'd have to have something on top and something on the bottom. Go ahead.
Can you reduce what you already reduced?
Yes. So how about 2/10? Doesn't that reduce? Sure. 2/10. 2 goes into 2 once. 2 goes into 10 5 times. Anything else? You just need something on top with something on bottom. No. So now I'm done. So I can multiply straight across right now. 4 times 1 times 1 is just 4. 1 times 5 times 5, 25. So my answer is 4/25. The other great thing about reducing first is that your answer will always already be in reduced form. You won't then have to reduce it again. If you do have to reduce it again, that means you missed something over here. But as long as you got everything, that's pretty much it. So, of course, now we make things more complicated because it's not just numbers. Now we're throwing in variables, right? So, but your rules are going to be the exact same. Let me give you an example of one. How about, let me see. Sometimes I think just making up my own is better. Oh, these are pretty good. Okay, let's say you wanted to do, here's a good one. X squared minus 3x minus 10 over x plus 7. And you were going to multiply that by 3x plus 21 over 6x minus 30. Your rules, your steps are actually the exact same as they were yesterday. first, you're going to factor everybody. Any numerator, any denominator that can be factored, I'm going to factor it. So I'm going to ignore these other things first. I'm going to factor that. I'm going to factor that. That's already done, and I'll factor that. So factor all four of them first. And then I get to reduce. Okay? So let's take a look at this first thing. I just made a stray mark that makes it look like a negative. It's not. That's just a positive x squared. So I want factors of negative 10 that add up to be negative 3. What would those be? Negative 5 and a positive 2. Okay, that one's done. Over here, what can I take out? 3. X plus 7. Okay, x plus 7, that one's already done. Over here, take out a 6, x minus 5. So now, just like I did with the numbers, anything in any numerator can reduce with anything in any denominator. So let's see, what do we have? Can I do those x plus 7s? Yep, they're gone, so they cancel with each other. X minus 5s. Anything else? Yeah, you can reduce the 3 and 6 with each other. 3 goes into 3 once, 3 goes into 6 2 times. Anything else? No. Remember, you can't do those 2's because that 2 is part of a binomial. So my answer is just now, I just multiply straight across. I just have x plus 2 over 2. That's it, guys. Yep. I don't have a top, but you can borrow this eraser if you want. Yep. So, does multiplying seem that bad? No. It's just like doing 2 of the problems from yesterday, just side by side. So, let me give you another one to try. How about 12x plus 48 over 6x minus 15, and we will multiply that by 4x squared minus 25 over x squared plus 9x plus 20. Oh, sorry. Okay, try that one, please. How do we do here? We got an answer? Okay, let's try it. What can you take out of the first one? 12. And what would we get left behind? x plus 4. Okay. This one, what does this turn into? That's the difference in two perfect squares. So you get 2x minus 5 and 2x plus 5. Okay? Those show up a lot, so make sure you're okay with those. Down here, take out 3. Thank you. 2x minus 5 would be left. And this here, factors of 20 that add to be 9. 4 and 5. Okay. Step 1 is now done. Everything is factored. Step 2, you get to come in and start crossing things off. So, let's see. What can I do? 2x minus 5 with the 2x minus 5. I can do an x plus 4 with an x plus 4. Anything else?
Wait, you take out 2 from the top later. You can do 12 and 3.
Yes, 12 and 3. 3 goes into 12 4 times. 3 goes into 3 once. Now I think I'm done. So, I'm just going to multiply straight across. 4 times 2x plus 5. On top and on bottom, I just have x plus 5. Do you have to distribute that 4 into that? No, you don't have to. In fact, I wouldn't. Just leave it. Just leave it. Is that so bad? No, if you can factor, I'm telling you, this is easy peasy. Now, we also have to divide though. Oh gosh. Dividing? That must be awful. Turns out it's not. Do you remember how to divide fractions? So if I ask you to do like 2/3 divided by, I don't know, 6, I don't know, 15ths. Who cares? Whatever. Do you remember how to divide two fractions? How? Keep, change, flip. Remember? Keep, change, flip. You keep the first fraction exactly as it is. You change the division and multiplication, and you flip this one over. So, 2/3 now becomes times 15/6. I don't know why I did that. Multiplication dot. And now I can do exactly what I was doing. I could reduce 2 and 6, 3 and 15. My answer is just 5/3. It's no different when we make it crazy algebra stuff. You just have to change it to multiplication and flip it. And then you proceed like you normally would. So let me give you a division problem. Oh, that's a good one. So if you got a division problem, literally step 1 is keep, change, flip. And then it's just a multiplication problem and you know where to go from there. So the first one, remember, the first fraction does not change. Leave it as it is. Change to multiplication and this guy gets flipped over. Okay, go ahead and finish that problem for me. We'll see if we all end in the same spot. Okay, you got it? Is that a yes? Am I going too fast? You tell me. No, we're good? Okay, so my first fraction, what does this factor into? Minus 4 minus 5, correct. I want factors of positive 20 that have to be a negative 9, so there they are. Okay, here, there's nothing to factor there. There's nothing for me to do. Same thing here, there's nothing for me to do, but this I could take out of 5. Okay, so now I get to cancel. Let's see, n minus 4's gone. What else can I do, if anything? 10 and 5, yes. 10 becomes a 2, 5 becomes a 1. Yeah, so n squared and n squared, aren't they going to cancel each other out? N squared, n squared. Keep going, there's more. 2 and 6. 2 goes into 2 once, 2 goes into 6 3 times. There's more. Yes, I have 1 m on the top, 7 m's on the bottom. What will I be left with? M to the
6.
where? Yes, m to the 6th. Is there any more? I don't think so. I think we are finally done. So what do I have left? I have n minus 5 up top, and I have 3m to the 6th on the bottom. So the division problems, they're just annoying because you have to rewrite it first, but they're no more difficult. It's just do that step first, and then you have a multiplication problem. So how do we feel about this? We're okay? All right, so let's try some. Stop this.